Okay, our final talk for the session and for the day is from Lieh, who's... Pardon me? So he's currently with the Institute of Systems Science at the National University of Singapore. So you may have won the prize for the person who traveled the farthest today to be at SATURN. Oh no, maybe Len came farther. Australia might count as farther, but... Oh. Okay, forget that. So before joining ISS, he spent his time in the IT industry doing systems integration projects, taking the role as an architect. And I think your slide already advanced. I think you win the prize for the longest title at SATURN. So I'll let you introduce that yourself. Thank you.
Yep. Okay, good afternoon. I need to walk around because in Singapore right now it's actually early in the morning. So I have still a bit of jet lag. Okay, this title is a bit long. Somebody actually told me that I should have just stick with service variability and multi-tenant engineering. It's going to be different from the previous two talks. It's more on multi-tenancy, multi-tenant engineering. So this is a work that we have been doing for 1.5 years, since early Jan last year. So we want to look into multi-tenancies, what are typical models that have been deployed for multi-tenancies, and does it scale? Does it scale in the sense that when there are more tenants onboarding, does it really able to satisfy all these new requirements? So before I go on, I just want to give some credits to my fellow colleagues. Trying to learn this. Chuck and Hans, I call it. Chuck, you might have known if you have actually attended any Java 1 conference. He's the Java evangelist. He always talk at this Java 1 conference. And Hans, we all actually met. We actually met each other at Sun Microsystems when we were working there. So before that, before Sun, I was actually at IBM Singapore for many years until we joined. We met in ISS and we work on this stuff. Okay, there are lists of students that want to just give some credits where they actually help in the projects. So this is not just a systematic review. So after the review itself, we actually did projects and we do some discussions with industry partners to find out what they really do for these multi-tenancies. So what I'm going to talk about in these 3 areas, it will be in these 3 areas. I know that this is the last session and the last talk, so I'll be the last hurdle for you to taking your dinner. So I'll try to make it short and sweet, right to the point. So basically, I will talk about multi-tenancy, introducing just what multi-tenancy is about, what are we trying to solve, what are the questions we're trying to solve in this area. And basically, based on our literature surveys, literature reviews, talking to industry partners, looking at academic sites and the industry sites, what are the typical architecture choices or models that can be generated, can be used. Basically, these are patterns. Okay, these are just patterns. And I will actually talk about two experience reports we have by doing some projects on multi-tenancies, and also how other industries in Singapore and the neighboring countries around Singapore are doing in multi-tenancies. Okay, my context will be more in the Singapore area because we are all based in Singapore. Okay, so there'll be, these are more in the Singapore part. Then, when I want to introduce multi-tenancies, this is a typical pictures I will introduce. This is actually a shop in Singapore. If you know, who has visited Singapore before? Okay, you know, we are quite a small country, so everything is expensive. If you almost, even you rent a shop, you can't really have a big space like, you know, in US, you can rent a big space. So there are actually business opportunities that entrepreneurs think of, which is, for example, this company called Box Boss. They actually provide this box for tenants to come in to actually rent one box by itself. They can actually display the items, display items in there. They customize whatever they want, but they'll be fixed within the box. Okay, so this actually plays very well in Singapore because a lot of tenants, in this case, will only pay to rent the box to sell their items. But they do not need to incur high rental costs for managing the whole shop. And to the, sorry. Okay, so for the service provider, in this case, it's also benefit for them because they actually can cater to much wider set of tenants. The pricing strategy for this kind of shop actually varies. So you can see that if you're actually renting a box nearer to the entrance at the eye level, actually typically price more than those actually at the bottom where the customers has to kneel down, or right at the top where customers really cannot see. So this is actually an example in the real world, in the real shop of multi-tenancies, where it works well for a country like Singapore. But in the IT systems, you can actually derive the same benefits by adopting a multi-tenancies structure. In a sense, the service provider itself, if they want to increase the market share, they want to reach out to a wider set of customers, okay, they can actually try to host this as a service and get the small and medium enterprise or even smaller companies to come on board. They actually can reduce their startup costs and the time to actually be on board. The tenant themselves do not need to care about or worry so much on the maintenance. And the service provider, on that sense, can actually increase their revenues. But there are 2 points that they have to be aware. On the service provider end, they need to make sure that there's a way they can share the resources. It doesn't make sense for them to actually create multiple instances for each tenant. In fact, you will not scale. So they have to worry about the scalability and maintainability part by sharing as much resources as they want. But on the other hand, the tenant also looks at what we call isolation level. That means the tenant themselves, although they are actually be a tenant on this particular hosted service provider site, they actually expect it to be isolated as much as possible so that they customize, can configure as much as they can. On the service provider end, when they talk about implementing a multi-tenant applications, they need to be aware of course, the typical function and quality part, but it's much more than just a single tenant engineering, single tenant type of application engineering. So each of the functional and the qualities, they need to look at how they can actually onboard as many tenants as they can, where the tenants could have different requirements, but they can still be hosted in the single sharing resources in a certain way. So in a nutshell, the problem we're trying to see, or we try to research in this area is how to actually balance off. Okay, balance off these two areas, where the service provider is looking at the sharing the resources part, but the tenant themselves is actually looking more towards the isolation. There's actually conflicting, if you look at it. Okay, the sharing and the isolation part. So there are 2 questions we're trying to address in this session, which is, first, what are the typical models that can be deployed or adopted for multi-tenancies? The typical models that's out there that's been adopted by the industries or been documented in some papers and so on. And the second, more important question is, does it scale? Okay, the second question is much harder to answer. Does it scale? Okay, you could have a model that actually satisfies a set of tenants, but how do you know that you will satisfy in the next 5 years where tenant requirements might change again? Okay, does it able to scale up? So the first part of our research, we focus on the digital review of what's out there. Okay, what's out there in the industries and in academics, in the conference, in the papers, and so on. So we actually generalize into 3 different areas that architects need to think about when they actually design a multi-tenant application. So in terms of the hosting, the packaging, and the binding. So basically, in terms of hosting, you need to think about, at the lowest layer, the process instance, the process execution of the application. Is it for many tenants, or is it dedicated per instance, per tenant? Okay, so that is one decision you have to make that actually differentiate a lot later on in the models. After the process execution, one more thing. The process execution could be the operating systems, whether they are sharing the same operating systems execution, whether they're sharing the same app server execution. Okay, so this process instance could be many layers on top of each other. Are they sharing for many tenants, or are they per tenant themselves? Okay, this will actually, if you look at it, the sharing, if you go into this shared instance, you'll be more towards the sharing objective of the service provider, while on the other angle, you'll be looking more on the isolation for the tenants. The other part will be the packaging. Okay, after the layer of processing, hosting, the process instance, how does the components are packaged? Are they packaged to serve any tenants? So typically, you are actually packaging up, and these are actually tenant neutral. They do not specifically serve a particular tenant, or it's actually tenant level packaging where you package up per tenant. Think of this as your normal Java EE applications. You can actually package up as a WAR file for all the tenants, or you can package many WAR files for one WAR file for each tenant. So the packaging part actually determines this next layer that typically determines whether you're actually sharing for all the tenants or per tenant themselves. And the last part, which is the topmost layer, is the binding. So when you design the architecture, the next level after the hosting and the packaging is how do you want to bind the variants, whether you want to bind at the static time, static binding during design, compilation, linking, or you want to bind it dynamically during deployment, loading, or during the at runtime. In fact, a lot of papers and industries adoptions are more focusing on the dynamic binding. Okay, so I have another slide on this, on dynamic binding. So basically, if you look at dynamic binding at runtime, they can form into three different areas, but basically they involve abstraction, configuration, and parameterization. There is some way to abstract out some rules, okay, abstract out the tenant, non-tenant specific part of it, and then you have a configuration which is tenant specific, okay, and then the parameterization to drive through the configurations and through the abstraction. So example is like template configuration, your JSPs, your JSF with additional tenant specific configuration so that they know which one to load. A lot of papers and adoptions are also looking into aspect-oriented, but much more is on the service-oriented architecture. So they use this style based on service-oriented architecture using business rules, business process engines, using business registries. They look up the business registries for the tenant-specific variants to invoke. So in a way, it's sort of like a shared data pattern. So you have a registry out there that actually you will invoke so that you will know exactly the variants for that tenants to be invoked. But if you think about this, all the three choices, okay, they actually 2 to the power of 3, 8 permutations. Okay, 8 permutations of all these choices that you, all these decisions you need to make. It actually can form up into 3 basic models. On the left side, we are looking at the shared instance. Okay, you are sharing the process instance. You're doing service level packaging, tenant neutral packaging, and dynamic binding. More of a fully shared model. This is what the service provider will want to achieve as much as possible so that they can share the resources, minimize their maintenance. But on the right side, if you look at it, it's more of isolation level. This is particularly what the tenant is looking at. They want to be as isolated as possible, can configure and customize as much as they can. So in that case, it will be more of a dedicated instance, tenant level packaging. And in terms of binding, it could be static or dynamic. Okay, so either choice will work. A lot of other permutations will be in the middle. Okay, you partially shared. In fact, a lot of papers actually either try to achieve this, but actually at the end, more of a partially shared. Because a lot of times, it's very hard to share the resources for all the tenants, but along the time when more tenants on board, okay, the tenant requirements varies a lot from the initial part, from the initial requirements. It could become so complex that it's no longer be able to maintain at this level. Okay, based on these architecture models, we actually went ahead and do a project. Okay, so we did a case study, not really a case study, a real project for a customer. Oh, sorry, before that, this is just a deployment view of the 3 types of models. Actually, you can't see really clearly. That is actually white color. Okay, so I am trying to show white color as in tenant specific, and at the back, more like a purple color, that will be shared. Okay, so in this case, all the things are shared here, and in the no shared, almost everything are actually dedicated to the tenants. Okay. And in the middle, it could be a partially shared, where some of the components are actually specific to the tenants. Some of the components are shared across. So I'm trying to depict a typical three-layer, but it doesn't stop you from actually describing this as many other layers. I could add an integration layer at the side, or some other layers in these three models. Okay, so based on the models, we went ahead to do a project for the customers. This particular project is what we call a content portal. So the main part of the applications of the customers is a content portal with some other services like catalog management, order management, and so on. They wanted to migrate. Okay, they want to migrate this multi-tenant, single tenant application, which is a Java EE application, to a multi-tenant. Okay, so based on what we have researched on, what we have known on the past models, we actually tried to do this in a Scrum, using Scrum methodology to actually migrate this part to a multi-tenant application. So we decided, of course, at the first part, the sprint 0, even before first sprint, we tried to actually derive the feature model and the baseline architecture for this. Initially, our thoughts, okay, we tried to go to a fully shared model as far as possible. But it's easier said than done. So there are some lessons learned based on this. What actually happened during the subsequent sprints? Okay, first thing is we all have this challenge. The product owner of this particular application, okay, is the company from the company side. They are also not very sure what is exactly configurable in this multi-tenant. Okay, they always usually sell as a single tenant application, and the customers can configure on their own. But so when we do this in the Scrum using a Scrum methodology, every sprint itself is always challenged to determine the scope of what is actually configurable and shareable. We try to start in a fully shared model, but eventually we ended with a partially shared model. That means some parts of the components are shared. Okay, we didn't go to a state of no shared, but we are also not sure whether, at the end of the day, does it really scale with a partially shared. So that is the initial deployment that we have for them, which is a partially shared model, based on partially shared model. And there are some, basically, takeaway is the interface layer, the presentation layer, and the persistent layers tends to be the first part that switch from a shared model to a shared to become dedicated for the tenant. Okay, so during the initial sprints, after the sprint 0, almost immediately sprint 1 and sprint 2, we actually have to change these layers to be more tenant level package rather than service level package. But the business layers actually did manage to maintain most of the shared components using service-oriented style. So we managed to share a lot of components at the business layer. So if you look at it, this is basically what we did. We did a feature model. Okay, what are the variants in this applications, potential variants? Okay, we generate the code and we deploy as a shared model. Partially shared model. So throughout the sprints itself, when the product owner changes the requirements, we have to go back to change here, regenerate, and on. So eventually, we actually end up with these shared models where we use JSF prime faces for the interface layer, the typical business layer with EJBs, BPEL engines, and then the persistent layers, we use Eclipse Link and some other stuff for tenant-specific objects. Okay. But we are still not sure. After this project itself, we're still not sure whether this will scale. Okay, so we went ahead and actually did another investigation of other service providers, particularly more in Singapore and in that regions. What are they doing in terms of multi-tenancies, and how are they coping with the tenant onboarding? Wow. Okay, so basically, there are some questions we have. This is not an online survey that they do. So practically, they are in a class, and we actually conduct 3-hour sessions. We actually conducted over 10 sessions, about 10 sessions, 3 hours each. And each session is attended by about 15 to 20 participants from different companies. They came from different domains, some from government, telecoms, financials. So we want to understand from them their way of implementing multi-tenancies, what architecture models did they adopt, and what are the key issues in onboarding. Okay, this is the first part, it more or less ties with what we understand in terms of our project. Typically, people tend to go for the fully shared model, dynamic binding, because to them it's the most obvious choice in terms of sharing the resources. But a lot of projects encounter what we call unfit. Unfit means that along the way, when new tenants on board, it's harder and harder to fit this tenant into the existing model, especially when the requirements of new tenants varies widely or the requirements of existing tenants are changing. Okay, how about the rest of the 45%? Okay, we actually did a check for the rest of the 45%. What happens to them? How come they can still maintain in that fully shared model? One typical feedback from them and understanding from them is those kind of projects tends to be more contained. So, for example, there's one that is actually meant for the government. Okay, in Singapore, the government, there's a lot of ministries. Okay, they actually built these multi-tenant applications to feed the ministries, to let the ministries, each of the ministries use. But in terms of the requirements, it doesn't evolve that much across the ministries. So they're able to still maintain the fully shared model. But for those other projects that other companies do that serve maybe the general public or other companies out there, they tend not to be able to keep to the fully shared model all the time. They have to switch, in the end, more to a partially shared model. Okay, there's last part which is very important here is there is a lot of comment about hybrids of the models. A lot of them eventually move from one model to supporting 2 or 3 types of the models. So this is actually what prompts us to think about how to really scale up this multi-tenancy. We do not need to restrict ourselves to be one model. Okay, we can actually try to actually put in mechanisms, components to support multiple models as whenever required. But the downside or the additional work we need to do is this what we call the tenant placement algorithm. We need to make sure how extend or customize this tenant placement algorithm to select the correct model at the runtime. Okay, so I'll give you a picture in a while, but I need to finish off soon, I think. So the key takeaway, one size does not fit all. If you understand your domain well, the requirements doesn't change that much. You can stick with a fully shared model for the start. But if you know the requirements, your domain is going to change widely. Okay, the advice is always go to a partially shared or even consider even a no shared. Okay, where we can have a maximum degree of service variability, maximum customization at the top, where you can serve as many tenants as possible. The other takeaway is you might want to think of this supporting of hybrids of architecture models. We doesn't have to restrict ourselves to be one of this. Okay, but the additional work that has to be done is in the middle. Okay, you need to have some placement logic, placement algorithm to decide based on the tenant onboarding when which of the model to go to based on cost, based on amount of reuse. Okay, those economic models before you decide which model to adopt. And there's another part that you need to have also a generator. Okay, so based on the algorithm and generator, it knows how to generate for the appropriate models out there. So we're actually doing this for our customers, the first customers that we are doing. So we are trying to extend their current architectures to be this, so that they have actually more flexibility in the future. Okay, so okay. That's it. So I hope you get something out of this. So basically, the problem definitions, we need to be concerned about both the tenant and the service provider. Okay, we cannot just think based on the tenants sharing resources, because the tenants' expectations will hit you later on in the coming years. So the architecture decisions will be the choices to be made and the models. And I shared through the 2 experience reports. Yeah, that's all I have.
Thank you. Okay, we have a couple minutes for questions.
Yes?
Yeah, okay, so you said, well, you need this generator. What is it generating? Configuration? Work files?
Okay, good.
Say a little more about that.
Yes, so basic.
For those of you who didn't hear, the question was, what is the generator generating?
Yeah, so it's generating initially without this. Okay, so these components are deployed to one of this. So they're actually customized based on just for one model, right? So this generator has to customize this between here, additional configurations for fully shared or partially shared, if they wish, whichever one they go to. It's not as simple as just a configuration file. Okay, there could be many dependencies in this model, or this model, or this model. So they have to make sure the dependencies are met.
So are they generating different deployment units?
Yes, deployment units, yes.
Configuration files?
Yes. Yes.
Have you looked into any security implications? Do you have any solutions?
Okay, actually, there's a lot of concerns that we need to meet for the tenant. So one part is, of course, the security. So if actually there is a security requirements, with this model itself, we actually try to go to a no-shared model to isolate as much as possible the data and the process. Okay, that is the typical move that we will recommend for the service provider for security.
More question? I guess it's me again. So if you can go back to that slide. So when I saw this, I guess I was wondering about the trade-off space between the choices. So, security would be one trade-off that you would make. But I'm wondering about performance. Have you done any prototyping or simulation to understand the profile of these different models under loads and what resource you saturate first?
Okay, our study that focus on the modifiability, not really the performance part. Okay, so to us, the performance in any time can be always scaled per the model. Okay, so we are not so concerned about whether can we scale up in terms of the CPU and the instances here. So that is not part of the study there. Okay.
Okay, well, so again, I'd like to thank our speaker.